Hey guys, hope you're all well. Hope the last couple of days have been good. In this video, I'm just going to take you through some of the applications of geometric sequences, in particular looking at modeling recurrence relations with compound interest, as well as what's called reducing balance depreciation. All right, so I'll get you to copy down all the notes that are here on the slide with your heading being geometric sequence applications. So in these, they involve two things, or can involve two things. With growth, where things are increasing over time, and decay, where things are decreasing over time. The most common example is in finance, where we use compound interest and depreciation, which is what we'll be doing in this video. So we've done a bit of simple interest in the past, where that's always calculated based on the initial principal. So principal is just your initial amount of money that's borrowed or invested. So for example, if you've got 10% of 5,000, that's $500. It's just going up by 500 every time. That's the arithmetic sequence where the difference between each term is the exact same. With compound interest, the principal changes every time period, and therefore the amount of interest also increases or decreases if it's a depreciation problem. So when we convert these problems into a recurrence relation, we take a value, or a calculated value, sorry, which is we refer to as R. Which is quite straightforward. You can see the formula here. It's just 1 plus whatever the interest rate is over 100. If it's depreciation, which we'll do one example in a moment, then we subtract rather than add. So I'll get you to write this all down. You may need to pause the video here to get this down. All right, so we have an example here. John invests $5,000 into an investment account that earns compound interest at an annual rate of 5.5% per annum. So remember, PA, per annum, just means per year. First part says to calculate R. All right, so the only information that we really need here is the interest rate, which is 5.5%. So there's that formula, 1 plus the interest over 100, and then substituting in 5.5, we get 1.055. So essentially, that's what we're going to be multiplying every term by to get the next term. So some of the examples that we did when I was there, we were multiplying by 3 or whatever. This time we're multiplying by 1.055. Next one says write a sequence for the first 6 years. So basically what we do is starting at 5,000, we just keep multiplying by 1.055 for the first 6 terms. When we do that, we get this. Remember to make sure to pause this video so you can write everything down as we go through. So the first year we had 5,000. After that, we multiply by the R value of 1.055, which gives us 5275. So we earned $275 of interest in that first year. But it changes every year. The interest increases because the principal increases. But same idea as what we've done in the past. Just multiplying by that same term, that same value, sorry, to get the next terms. Then lucky last year, to write that as a recurrence relation, it would look like this. So T1 equals 5,000, the initial amount, or a first term. Tn plus 1 equals that R value of 1.055 Tn. So all that means is we're starting at 5,000, and to get the next terms, we just keep multiplying by 1.055. Make sure to pause this and copy that down. And lucky last, reducing balance depreciation. All right, so here we've got a car. It costs $8,500 and depreciates by 7% each year. So remember, depreciation is where things lose value over time. So for this first one, we can calculate R. Much the same, except this time we are subtracting rather than adding in that R value. So 1 minus the interest over 100, my interest being 7%. So 1 minus 7 over 100 is equal to 0.93. So that's my R value. And then finally, with that last one, write the value after 4 years. Same thing that we've done there, which is multiplying by 0.93 every time after every year. And you can notice with this one that the value that we're losing is decreasing because that principal is decreasing over time. And down the bottom there, we have the recurrence relation for this one. T1 equals 8,500, Tn plus 1 equals 0.93 Tn. So guys, hopefully a bit of that made sense. Refer to the lesson plan now to see what questions you need to be doing. Make sure you're checking your answers as you go through. Some of these questions are a bit wordy, so download the solutions from Compass so you can check your answer as you go through. Good luck.